So this second chapter is going to be about radical functions, and in this first section, it is specifically about radical function and transformations. So it's kind of a continuation from chapter 1. So first off, just to start, we're just going to talk about the parts of the radical. So what is a radical? So a radical is something like this. There's n, this bracket thingy, and then x. So the names of these different parts, this n here, could be different numbers, and that is what we called an index. Whatever number is under this kind of bracket thing is what we call the radicand. And finally, this bracket thing that I've been calling is the actual radical. And something you may recall from Pre-Calc 11 is depending on what number the index is, so if index is even, so even numbers are 2, 4, 6, etc., then x, or the radicand, must be greater than 0. And if index is odd, so odd numbers being 1, 3, 5, etc., then x, the radicand, can be all values. So if the index is odd, then positive, negative does not matter. So even though this chapter is about radical functions, which can be many different indexes, we are going to spend most of our time looking at square root graph. Okay, so let's just take a look at what that base graph will look like. So square root graph means we're talking about y equals to root x. You know, that's our base graph. I'm gonna just write that down. This is our base, okay? So to figure out what that will look like, a table of values will become very handy. So we're gonna go with 1. So when x is 0, y is 0. And now let's just, looking at our graph, our function here, we're just going to find different values of x that makes it easy to square root. So the next number that's easy to square root is 1, so y will be 1. And then 4 is another number that's easy to square root, that will give us 2. And then 9, 3. So now let's just plot it up. So 0, 0, 0, 0, 1, 1, 4, 2, 9, 3. So get used to these key points. And it's gonna curve kind of like so. And it's kind of like half a parabola sideways. That's basically what a square root graph looks like. Okay. So let's look at our first example here. So I'm just going to zoom in a little bit. So this is basically what we've been doing in chapter 1, except we haven't really been graphing square roots until now. Okay, so first of all, remember our base, it's going to write on the side here, base is y equals to root x, okay? So we are manipulating that. So from here, we have this first one here. This is basically our a. This here is our h. And this here is k. So what transformations are we looking at here? So we have, in our a, we have vertical reflection. And we also have a vertical stretch by 2. So it's actually a vertical expansion by 2. That's another way of saying it. The 3 So we have a horizontal translation, which is going to the right 3. And then we have a vertical translation up 1. So now that we know our transformations, let's just do our mapping. So we know xy is now going to become, so there's only one number affecting our x, so it's going to move to the right, so plus 3. And then we have negative 2y plus 1. So remember, our key points are 0, 0, 1, 1, 4, 2, 9, 3. Now it's just a matter of calculating it. So x will be 3, 4, 7, and 12. And the y values will be 1, negative 1, negative 3, and negative 5. So now that we have our transformed points, let's plot it. So 3, 1 is here, is here. 4, negative 1 is there. 7, negative 3 is here. And well, 12's kind of off the charts, but it's gonna be somewhere out here-ish. So let's just connect the dots so at least we're heading in the right direction out. So it's gonna be somewhere like, something like that. And this is our graph. So we're not done yet because we still need to figure out our domain and range. So domain, again, is x values. So the domain, well, the x values start from 3 and can be anything bigger than 3. So the domain will be x, is anything bigger than 3. So x must be greater or equal to 3. And the range, well, that is anything that is lower than 1. So therefore y, wrong color, let's go back to blue. So y must be smaller or equal to 1. And that's it. Okay, on to the next question. So now that we've graphed it, let's go with a scenario where we're given a graph. Now, what is the equation? So to start, I'm just going to graph that base square root graph first. So again, it's 0, 0, 0, 0, 1, 1, 4, 2, 9, 3. And in this particular case, we do have more room. Pen mark not coming down. Why is it not? Oh, click away. Oh, there you go. That's not the right spot anymore. 9, 3, and 16, 4. That will be the next one in line. So I'm just going to connect this just so we could visually see our base radical graph. So this is that base graph before we transform it onto the red one. So first, again, we always have to look at A and B before H and K. So I know it might be very tempting to just translate it to the right and up, but always work with the stretches first. So the points I will be comparing are, I'm going to actually compare, it's hard to see, these 2 points here on the blue graph, and then I'm going to compare, I guess here was the start of the red one, and the next intersecting point would be that point up there. Okay, so when you look at the height of the base graph, the vertical, I'm looking at 1. And now on the other graph, it's 2. So from 1 to 2, I know my A, or my vertical, must have a vertical stretch of a factor of 2. And looking at my horizontal, well, it's 1, and right now it still remained 1. So there has been nothing changed with B, so I'm just going to leave it out. So now that I know it's a vertical stretch of 2, if I stretched it up, now I could translate it. And since 0, 0, you know, no matter how you stretch the point 0, 0, it won't change it. So from there, we know we can now move it 1 to the right. So that means h is equal to plus 1. And we will be moving 1 up. So that will be k equals to plus 1. And knowing all these transformations, let's write it down so we know y equals to 2 f x minus 1 plus 1. So if we're just talking about the function, and I guess we'll need to, if we're going to write in this function form, we need to be specific that our function is in fact a square root, okay? Or if we're going to write it in the square root, it's going to be y equals to 2. Remember, our function is the square root, so anything horizontal will fit under this little bracket thing. So it will be x minus 1 plus 1 on the outside. Okay, so these are your two possible equations for this graph. Moving on to the next question now. So something a little different. So find the equation of a radical function with domain x is bigger than 4 and range is smaller than 2. So it could be any possible equation. There's multiple answers to this one, but I'll just show you one of the many examples. So I'm just going to sketch a graph here. So domain are all the x values. So it must be greater than 4. So it's going to be, say, somewhere here on the right side. Say that's 4. And it must be greater than that. So therefore, anything on the left of this line is out. So I'm going to just cross that out. Okay. Now we know y must be smaller than 2. Okay, maybe I shouldn't have crossed this much out. 2 is, say, like somewhere there. Okay. Oops, sorry. Never mind. I'm thinking negative 2. Positive 2. Positive 2 is up here. So 2. And y must be less than that. So anything to the left of the 4 is gone. And since it must be less than 2, so anything above the 2 must also be gone. And it's saying my radical function must fit down here. So remember, a radical function typically would go up like so. Now, if I'm starting from this origin point, if I'm going up, well, that's going to cut into the space that I'm not supposed to be according to the domain and range. Therefore, my radical graph must be going down. So let's erase that last line. So I know the starting point, the end point, must be at 4, 2. And to have a radical graph, the only way is to kind of go down here. So it's got to be a reflected square root graph. So to make our lives easier, it's probably the easiest just to go with a graph that has no horizontal or vertical stretch, but you can be creative and throw in one if you wanted to. And we're just going to say this is simply a graph that has vertically reflected, and we know it has a horizontal translation, right 4, and we know it has a vertical translation up 2. So that means in the equation, we're looking at y equals to vertical reflection, right 4, so that'll be minus 4 plus 2. Right there. Alrighty, so last question of these notes. So first, find the equation of a radical function. Find the equation of a radical function with an endpoint at -2, 5 and passes through 7, 1. So first, let me just make more space for myself. There we go. So to do this question, let's first just sketch out our points. So we have an idea where they'll be. So the end point is -2, 5. -2. It's like 1, 2, 3, 5, and to 7, 1. So 1, 2, 3, 4, 5, 6, 7, 1. So -2, 1, 2, 3, 4, 5. So -2, 5 is somewhere here-ish. 7, 1 is somewhere there. Oops. And we know this is, oh, no, that's -1 again. Why do I always want to put, oops. It's 7, 1. So we're just going to connect it something like so. So we know this is a radical graph. It's going to look something like that, okay? So again, I'm just going to draw in that base radical graph just for reference. So 4, 2, it's gonna, this graph is something like so, okay? So comparing our base graph to the graph that we need to figure out an equation for, it's very clear that there is a vertical reflection. Now, we need to figure out our other stretches, if there are any, before we move on to translations. So right now, let's just look at, what is that vertical distance between these 2 points? And since it's going from 5 down to 1, we know the vertical height is 4. Whereas when we look at our normal graph, and let's just look at the width too. We'll just compare these two first. And the width here from -2 to 7, we're looking at 9. So comparing with our blue graph, we do also have some key points where the width is 9. Because remember, the key points is 1, 0, 0, 1, 1, 4, 2, 9, 3. So to make our lives easier, I'm actually going to refer, because I think here is 9 basically. Oops. All right, let's just erase. I'm going to compare with these 2 points where this is basically my 9, 3. I'm going to compare with the key points on my base where I have a width of 9 and a height of 3. So now I don't even need to worry about a horizontal stretch. Okay, so there's no horizontal stretch. But I do need to figure out that vertical stretch, what I'm dealing with there. So since I'm going from 3 to 4, that means that if you think about it, I have, for my vertical stretch, I'm going from 3 and I have some a value that I'm multiplying by and it gets to 4. So that means that stretch value must be 4/3. So that means I have a vertical stretch of 4/3. And now that I've done my stretches and reflections, now I can finally translate it. So from, again, that 0, 0 point, I know I have moved horizontally translated 2 to the left, 2 left. And then afterwards, I have moved, let's see, what is that? 5 up. There we go. So now with all my transformations done, I could write out that my function is negative, that's my vertical reflection, 4/3, that's my A, or vertical stretch. There's no B, so it's just X, and it's 2 to the left, so it's +2, 5 up, +5. And here is one possible solution. My challenge to you is to work on the same question and find out what's another possible equation that will fit the same scenario. And that's it for 2.1.